Hey everybody, this is Larry. This is me on August 2nd of 2024 trying to do an extra bonus problem that I haven't done yet. Hopefully not a hard one. Maybe I don't know if I can do a hard one right now. I want to go for a run and I have a very long one. But okay, either way, we have an easy problem, so that'll be good. 800 similar RGB color. Okay, so you have some RGB color, and the similarity is just I don't know why they say YX like this, but okay. Okay, and this is a hex number, right? Wait, what? Alright, let me... I think I skipped ahead a little bit and I got confused. Okay, the given return number that's the most similar to given color and has a shorthand. It can be represented as XYZ. Okay, I see. So basic, yeah, this is an HTML thing maybe. I don't know, or like what you might call CSS thing, or maybe HTML, I don't know. Either way, so it could be the shorthand because it can be expanded. Okay. And then we're just trying to figure out when that is the case, right? Okay, so I think there are a couple of ways you can think about this, right? Now we want to, let's say, parse out the RGB, right? So let's say maybe we have a parse function, we have a string, and basically we have a 2-digit string, and yeah, it's 2-digit hex, right? So it's just going to be, I feel like in Python there's a way to do this, but like, can I write? Well, maybe I'm thinking of another language. Python int base hex, right? Or something like this. Like, I think like int 16 works, but maybe I'm wrong, right? Like return int 16, maybe, right? Let's try real quick. Yeah. Let's just try AA. Oh, this is lowercase AA actually, and see if it gives me an error. Okay, no, so okay, that's consistent. Is that right? A is 10, so 10 is 170. Sounds right? So okay, so that means that the parsing function is good. So then now we can say RGB is equal to parse. I don't know, color. What's it called? 13. Maybe you could do this in a for loop. I don't know. It's fine either way. I think maybe. I don't know. It's yeah. Oh, I spell color without a U. Oh, that's because of this one. Okay, fine. But yeah. Maybe actually we'll just write C for colors and then we can match it, right? And of course, the naive way you may think about is just that there's only 16 possible things for each one, right? So you can do something like for I, for I in range of 16, for J in range of 16, for K in range of 16, and this is going to be good enough, I think. But in the interest of always optimizing, why is this negative though? Most similar, highest similarity means the smallest difference, right? It's a little bit awkward. Okay, fine. I don't know. Highest. Okay, I mean it's fine, but yeah, so you can do this, right? But sorry, I'm just kind of double checking real quick, and it'll be fast enough. 16 to cube is fast, it's fine. But I think as you're trying to improve, as you're trying to get better, what you should try to do is try to figure out how to optimize these things, right? And here, you look at the formula. Maybe we'll just write it out actually. Okay, so if I is the color, then we have I times 16 plus I. So the solution, the score, if you will, is going to be this. This is the number. I was going to change like away stuff, but I guess it doesn't matter. So let's do this, right? So this minus r square, just write this way so that I'm, yeah. I don't know what highest means, so I'm just going to keep it, just going to negative everything. So yeah, yeah. And maybe instead of writing this formula out, maybe I'll just write, double up, maybe x, return x times 16 plus x, right? So then now we can just write, maybe double is a little weird way of naming it, but, and also that's wrong, it should be j or I. This one's I, this one is j, right? Whoops, green plus k minus b, right? So that's your score or your penalty depending on your record. I think we're supposed to get the lowest because the highest is on the negative number, so where best is equal to infinity, and then yeah, best color or whatever is going to be empty string, right? And then here we want yeah, if score is less than, because we want to minimize this, right? Yeah, then we score is equal to, oh, the other way around. Best is equal to score, and then best color is equal to get color ijk, say. And we just write more helper functions. I guess this is RGB anyway. I do want to Python convert to hex. Oh, there is a hex function. Okay. Do we double up? We do double it up. So yeah, so we have hex of r times 2 in that. Well, let me print this real quick. String in was in not double. Oh, whoops. Oh, whoops. A little bit sloppy today. But this is kind of involving for easy palm. Yeah, okay. Don't know why this only goes to 1. Hex of because I goes to 16. I mean, did it just run out of stuff? I'm so confused. Like, if it gives me like an output limited or ... thing, it's fine, but I'm wondering why. Yeah, that's kind of wild. Why does this? Oh, because it. Okay, sorry, I see. Because this get color no longer improves, so we don't call this function. Okay, that's fine. But yeah, this is actually the format that I expected in, because binary is in a similar way. So then now we have this thing, right? We skip the prefix. We times it by 2. So maybe this is going to be just like get single color of R, right? Just return this thing. And then now we can do, maybe that's a little bit wordy, but well. G plus, right, and also the hashtag thing. So yeah, so then now this looks good. Yeah, looks good, looks great, right? Yeah. I mean, this is a little bit slow, but we actually expected this because it's 16 cube. And I don't think that matters that much, to be honest. I think it's just that I do a lot of funky things. But that said, you know, one thing that you can do to kind of see if you find an improvement is, yeah, is looking at this scoring function and realize that actually these are independent, right? Because this dimension is separate by this dimension is separate by this dimension. So you can actually kind of, well, just take it out, right? One way that you could do that is just that maybe I score is just you go to here, right? So this is the first optimization that you could do. Maybe J score is you go to this, and then here we just left, you know, just for consistency, K score is you go to this thing, and then you have I score plus J score plus K score. So now already this should be a little bit faster, maybe not that much, maybe, oh, okay. Just because if nothing else, you don't do this operation or this operation a lot. But then now, furthermore, you can see that actually, you know, this function doesn't depend on here, right? And when we try to minimize, we can actually, this is how you know, when you minimize this function, actually, the minimization of all these are not, like, they don't affect each other, right? So then now you can maybe do you know, you could actually separate them out. So maybe like you could do a get min color of a particular color, and then now you do it for range in 16, right? So best color is equal to best is equal to infinity, and then just do I score is equal to double sub I minus R, right? And then same thing, if I score is less than best is equal to I score, and best color, well, I guess we would is equal to get single color of I, right? And then we just return best color, right? And then now we have this, now we can separate the function out a little bit more, right? So then now we can say, yeah, get min color of R, right? Plus get min color of G, plus get min color of blue, and then we just return this hashtag thing plus here, and we don't need any of these, right? Oh, okay. Did I mess something up? Oh, because I used R instead of C. Okay. Yeah. Give it a submit again. Right. So now you can see it's even faster because we went from 16 cubed to just 16, right? Or 16 times 3, sorry. Right. So this is definitely much faster. So actually, even now, right, there's actually still more optimizations that you can make. This is an easy problem, which allows to kind of make, you can see it make these incremental progress. I'm not going to make this one, but the thing to notice is that this is a parabola, right? I mean, I think we did actually, like, it was a bonus, like a Larry bonus question yesterday or the day before, but you can see how this is a parabola, right? And a parabola, there is a it's a positive facing parameter. I forget what the terms are. It's been too long. It's high school math, and I haven't been in high school for a long time. But it's a parabola, so that means that there's a min function, and if there's a min function, you could binary search for it or bisect for it, if you like. So yeah. So I mean, obviously, in this particular case, log of 16 is not that much of a difference between 16 because there's just like a lot of constants and going on. But you can see how if this was a bigger number, then you would bisect this number to get it, and yeah, and that would just get you much faster as well, right? And then you could do that. But yeah, but that's pretty much all I have for this one for now. Yeah, I mean, what is right? I don't know. That's all I have. They just call it all one. Okay, rounding. What's rounding? Oh yeah, I guess actually I didn't. I was thinking about that one, but I just forgot about it at all. Yeah, you could also just do the math, as they say, right? Because you could probably solve for this, because like this is equal to some number or approximately equal to, and then you just do like one or the other. Yeah, that's my fault. I actually forgot to mention that one, so I guess it's good. But that's all I have for this one. Let me know what you think. Thanks for watching. Stay good, stay healthy to good mental health. I'll see y'all later and take care. Bye bye.